Hello everyone, welcome back to my channel Learn Math with Preeti. The topic which we are going to study today is indices, standard form and surds. So let's start. So indices, standard form and surds. So we will try and cover at least indices and standard form in this lecture, and we will keep surds for the next lecture or for the next video. Okay, so let's start with first word, indices. As we all know, whenever we start a topic, the first thing we need to understand what is the meaning of the word given, or what does the topic say and where is the topic used. So this indices we study everywhere. For calculations we use indices. Now what is the meaning of this word indices? Indices actually is the plural form of the word index. Okay, now what is the meaning of the word index? Index simply means power, right? Whenever we write something raised to the power, so that power is called index, and when there are too many index together we call them indices. So for example, if it is 6 raised to 4, right? So this number which is down is called as our base, and this number is called as the power or index. And when we have these numbers more than 1, so they become indices. So when we have more powers, it becomes indices. So this number is the base, and what is written at the top in small is the power or the index. Now 6 raised to 4, what does this mean? What does this power means? The power means that this number, the base, is repeated these many times. So now this is 6 raised to 4. That means they are telling us that 6 is getting multiplied how many times? 4 times. So we do 6 into 6 into 6 into 6. So what do we get? Actually we get 1, 2, 9, 6. So the meaning of this is 6 raised to 4 means 6 is getting multiplied 4 times. So this is a short form of writing, because not necessarily every time the power will be small. Sometimes you may have a very big power. So writing this is lengthy. So we write it like this. So this is our base, this is our index. This is how we write after in the simplified form. Okay. Now we know what is indices. So we know what are indices. Now next is we need to understand some rules. Like we had rules for significant figures, we have some rules for recurring decimals. Similarly, we have rules for indices also. Those rules are called as the laws of indices. Okay, there are many laws, but first we will study 3 laws. The first law says that a raised to m into a raised to n is equals to a raised to m plus n. The law, as you see, the law says if the base, there are two numbers, okay, which are having powers. If the base is same and they are in multiplication, you can add the powers directly. Second, this multiplication goes to division, and here the plus becomes minus. This is the second law of indices. The third law is a raised to m the whole raised to n is equals to a raised to m into n. This law says that when there are more than one power to the same base, what do we do with the powers? We simply multiply the powers. Now let's take up one small example to understand this law much better. It's very easy, but we'll just take a small example and understand it more better. Okay, so if I say 4 raised to 2 into 4 raised to 3 into 5 raised to 2 into 5 raised to 4, right? So now if you see, there are 4 numbers here, but as we know, we apply the law only and only if the base is same. So if you see, the first 2 numbers the base is same, and the last 2 numbers the base is same. So we will take first 2 numbers together. And what do we do with the powers? Now if the base is same and they are in multiplication, we simply add the powers. So simply add the powers. 2 plus 3 and 5 raised to 2 plus 4. Now the answer is 4 raised to 5 into 5 raised to 6. Now you cannot simplify furthermore. Why? Because the base is not same. So you cannot apply this law here. but you can apply this law at the first step, because there are two numbers which are having the same base, but when you reach to the last step you cannot apply any law, because both the numbers or both the base are not same. So the first law, I hope it's clear. Now we will take up an example for the second law. Simple. We will just take up 4 raised to 5 divided by 4 raised to 3, which is equals to 4 raised to 5 minus 3. So the answer is 4 raised to 2. So the second law also is, I think, well understood. Now let's take up an example for the third law. So if we have 6 raised to 2 the whole raised to 4. So now if you see, the base is same, only there is only one base. Okay, but there are two different powers, or maybe sometimes there are two same powers also, but there are two powers. So what do? We just multiply the powers. So 6 raised to 2 into 4. So this becomes 6 raised to 8. So I hope it is clear how to solve using these laws of indices. Okay, so these are the first three laws of indices. Now next, there are many more laws, but let's take up a few examples which we have done this one law example, right? Now we will take up some examples which are having a combination of laws. Okay, not one law, they are having all the three laws in one question. So we'll take one example like that also. 2 raised to 3 the whole raised to 4, okay, into 2 raised to 5 into 3 raised to 9 upon 2 raised to 9 into 3 raised to 4. So now if you can see, there are all the three laws getting used here. Here first, in the first number only, if you can see, there are two powers. So we will use the third law. There is multiplication, we will use the first law, and these two are in division, so we will use the second law also. So let's start. So in this the power will be multiplied, right? So this becomes 2 raised to 12 into 2 raised to 5 upon 2 raised to 9. Now what did I just do? I am just taking or grouping them together. The same base numbers, I am grouping them on one side, and the other numbers which are again the same base, I am grouping them on the other side. Nothing else. Everything remains the same, just I am grouping them, okay, according to the way I want to solve. So now this is multiplication. In the numerator there is multiplication and the base is also same. So what do we do with the powers? We simply add the powers and the denominator will be as it is, and here also 3 raised to 9 upon 3 raised to 4. Now if you see, this is also in division, this is also in division, and the base is same here also base is same. So now what we will do? We will just subtract the power. 2 raised to 17 minus 9 into 3 raised to 9 minus 4. So what will be our final answer? 2 raised to 8 into 3 raised to 5. Right? So this is the final answer. You cannot solve any further because the base is not the same. Okay? So we just did one example. So we got a clear idea how to use all the three laws together. Now next, one more law is there, that is zero index law. As the name itself is self-explanatory, zero index means the index will be 0. So if for any number or any variable, if the index is 0, the answer always will be 1. Always remember, anything raised to 0 is always 1. You just write 1 directly, whether it is 4 raised to 0, whether it is 5 raised to 0, whether it is 99 raised to 0. Anything raised to 0, we always write 1. So this is the zero index law. Okay. Now the next law is negative index law. This also gives a very nice explanation at what law is this. Negative index means here the index was 0, here the index will be negative, but generally if you see, the index is never kept as negative. So how do we convert that negative index into positive? So this law will help us to do that. So this is a raised to minus m. If the index is negative, what do? We simply take the reciprocal of the base and the power will become positive. So what is the reciprocal of a? It will be 1 upon a and the power becomes positive. So simply whenever we have negative index, we take the reciprocal of the base. Keep that thing in mind. we take the reciprocal of the base, not the power, because sometimes there is negative power and that is in fraction also. So don't do this mistake. This is a silly mistake done by everyone. So please remember that we take the reciprocal of the base and not the power. So okay, so we take here the reciprocal of the base so that the power turns positive. So okay, so this was the fourth and the fifth law, and this is well understood. So if I say, let's take up a number here also, 5 raised to minus 2. So what do I get? I'll take the reciprocal of 5. What is the reciprocal of 5? 1 upon 5, and the power will become positive. So that is all what is negative index law. Next, there are more indices. So we'll go on to the next topic, which is exponential indices. Okay. Now, what is the meaning of indices? We know. What are exponential indices? So these are indices where the power is not known to us, or they are increasing rapidly. Exponent actually is which is increasing rapidly, right? And here the power is not known to us. Till now what we were doing, the power were already given in the number form, right? Here in exponential the power will be in the variable form. So if I say 2 raised to x, 3 raised to y, 4 raised to a. So if you see the power, it's unknown. It's not known to us. So these are exponential indices. Now how do we actually solve exponential indices, right? When we have exponential indices, how do we solve? Normally we used to find the value of x and y, but when they were given in a form of equation, this is not an equation. The power is the x and y or a. The variable is given in the power. How do we do that now? So let's take up an example. 5 raised to x will be equal to 625. If they are giving us this question, 5 raised to x is equals to 625. Okay. Now we have to find the value of x. What comes into the mind? That 5 will be multiplied how many times to get 625? It's not always easy to multiply a number and get the answer. Simple trick. Very easy. 5 is the base here and there is an equal to sign here. That means this and this side should become equal, right? Right. So if the base is 5 here, can I get the base 5 here also? Yes. This becomes 5 raised to x. 5 I multiply how many times to get 625? I guess 4 times, because 25 is 625. So 5 raised to 4. Now they say if the base is same, so the power is equal. So this is x is equals to 4. So we got the value of x. Now not necessarily always it will be x. There can also be an expression here. So if it is 3 raised to z plus 2 is equals to 27. We follow the same rule. First thing, we try and get the same base on the right hand side. So the base here is 3 raised to z plus 2. 3 is the base. Can I get the same base here? So 3 raised to how many times will give us 27? 3 raised to 3. Now again, if the base is same, power becomes equal. So we will write z plus 2 is equals to 3. Now I have to find the value of z. So what is the value of z? Simple, z is 1. Right. Now if you want, you can just check here. 3 raised to 1 plus 2. That is 3 raised to 3. Am I getting 27? Yes, I am getting the answer. Right. So we could find the value of z. That means in exponential indices, there will be a variable in the power. And we have to find the value of that variable. Okay. The next subtopic here only is this standard form. That in the first we studied indices. I told you the chapter is indices, standard form and surds. Everything is in one chapter. So now we will move on to the standard form. That is also a part of indices only. That comes in indices. Standard form means a form which has power. So that is also under the topic indices only. That's why we do it under the topic indices. Okay. So how do we understand what is actually standard form? Okay. How do we understand that? What is standard form? Normally whatever numbers we write, sometimes are whole numbers or integers or fractions, right? So there is a way of writing all the numbers, right? So not necessary all numbers are small. Sometimes you will have to write very, very small numbers, right? Sometimes you will have to write very, very large numbers. At that time we need this standard form. We require this. So in standard form we have again two types. In standard form, not two types, we can say there are two indices in standard form. First is the positive indices, next is the negative indices. That is very, very big numbers. If they are very big numbers are written as positive index, and there are very small numbers are written as negative index. Okay, for now you understand, very big numbers, they will always have positive index. Very small numbers will always have negative index. Now first we understand what is standard form. Standard form means we write any number which is very, very big or very, very small in a given form, and that given form is a into 10 raised to n. Now this n will be positive here and negative if they are small numbers. Okay, so this is the way of writing the number in standard form. But not only a into 10 raised to something, there is one more thing, a. What about a? There is a condition for a also. So this is 1 less than equal to a less than 10. That means 1 can be ranging from, a can be ranging from 1 to 9. 1 up to 9. It cannot go more than 9 and it cannot go less than 1. It can be ranging from 1 up to 9. Not more than 9, not less than 1. So these are the two. This is a way of writing standard form, and this is a condition for writing this number a. Okay. So this is well understood, I hope. Now we will try and take up an example for this also. How do we actually write the number in standard form? Okay. So I will take up a number 3300. Okay. This is a number. Now there are three ways in which I will write this number, and let's assume you all will comment down the answer, that which of, I will give you the answer of course, but then what did you think which is the correct one? So first will be 3.3 into 10 raised to 3, then second will be 33 into 10 raised to 2, then the last one will be 0.33 into 10 raised to 4, right? These are the three ways of writing. Now everywhere if you see, it is a into 10 raised to n form only, right? This is a into 10 raised to n form only. But what was the rule which I told for a? That 1 less than equal to a less than 10. That a should be ranging from 1 to 9. So in which option? Option 1, option 2 or option 3 are we getting satisfying this condition? So this condition is being satisfied in the only first one, right? Because 33 is not in between 1 to 9 and 0.33 is less than 1, but 3.3 is in between 1 to 9. Okay, so this is the correct standard form. These two are not the standard form. These two are a way of writing the same numbers, but we cannot call them as the standard form. Okay, so this is the standard form. Now we understood how to write the number in standard form. So let's try more numbers, right? So if I tell you the number is 4, 8, 1, 2, 3, 4, 5, 6, 7. Okay, there's 7 zeros. So this is a very big numbers, right? So every time if you write this big number, it's not possible. So that's why there's a standardized form given, which is used by everyone, so that there is no confusion. So that is this. So now I will write this in the standard form. So should I write 48 into 10 raised to 7 or 4.8 into 10 raised to 8? Obviously 4.8, because my a should lie in between 1 to 10. So this will be 4.8 into 10 raised to. What will be the power? Just count the numbers from here. 1, 2, 3, 4, 5, 6, 7, 8. So the power is 8. So this is the standard form of writing this number, which is very, very, very big. Right? Now we just don't only write the numbers in standard form. Sometimes there are calculations and we have to perform those calculations and again convert the answer in the standard form. So suppose we have two numbers, 4 into 10 raised to 5 and 8.3 into 10 raised to 4. Now to multiply these two numbers will become big, right? This will become around 400 means 400,000, and this also will become 83,000, right? So to multiply such big numbers, instead, very easy, just multiply the number here. If you multiply 8.3 and 4, what do you get? 33.2. And then what is remaining? 10 raised to 5 and 10 raised to 4. If you see, these are again indices. The base is same. The power is in, and these are in multiplication. So what do we do with the powers? We simply add the powers. So I got 33.2 into 10 raised to 9, right? But is this the standard form? They have asked us to write the answer only in standard form. But this is not the standard form. How do I write it in standard form? I have to shift this decimal here. So this becomes 3.32 into 10 raised to 10, because the decimal point increases. It's moving towards the left side. So this is the way of calculating and then writing again the answer only and only in the standard form. So this we did for all the positive. If you see the index here, or if you saw the previous page, the index was always positive because they were big numbers. Okay, they were for big numbers. Now as I told you, there are small numbers, very, very small numbers also, right? So for that, what do we do? For that, we will have negative indices. That time we will use negative power or negative indices. Again, the rule remains the same. We write in the form of a into 10 raised to n, and 1 is less than equal to a is less than equal to, is then less than 10, not equal to, sorry. It's less than 10. Okay. So now let's take up an example. 0.000053. Okay. Here, this is a very, very, very small number, right? This is less than 1. You cannot call this as a standard form. That means the decimal point should be here in between 5 and 3, right? Because it will become 5.3. If you do it after 3, it will become 53, which does not satisfy this condition, right? So we will do 5.3 into 10 raised to. Now the point is shifting towards the right. But how many steps? 1, 2, 3, 4, 5. This becomes minus 5. When the point is shifting towards the right, we are doing negative because very small numbers, right? Minus 5. So here we use negative indices. Our indices or the index is minus or negative because the number is very, very small. Now if there is a number given 0.4 into 10 raised to minus 10, already it's given in a into 10 raised to n form, but does the a satisfy the condition which is given here? No, because this is 0.4. It cannot be 1 or greater than 1, right? It is less than 1. So what do? I need to shift the point here. So this becomes 4 into 10 raised to minus 11. So this is how you get any answer which is in the simple form or which is given in a different form into standard form for negative indices, right? So positive indices, negative indices, standard form is also done. Now there are two more laws which we are going to learn, and those two laws are being used for different indices. Those are fractional indices. Okay. Now this name is also explaining a lot of things. That the same way we had exponential indices, in that what do? There were variables up, right? Now fractional indices, the name itself says it all. That means the power will be in fractions. So if I say 27 raised to 1 by 2 or 4 raised to 1 by 3 or 9 raised to 5 by 2 or 2 raised to 3 by 4, whatever it is. The power every time is in fractional. So these are called fractional indices because their power is in the form of fraction. Now for these again we have two more laws. A raised to 1 upon n will be equal to nth root of a, and the last one here is a raised to m upon n will be nth root of a the whole raised to m. So these two laws we will use to solve the fractional indices if the indices are given in the fraction form. Suppose they tell you it is a raised to, or suppose 5 raised to 1 by 3. So what do we simply do? This will be nth root. So this is the root. So I will write cube root of 5. Similarly, if you have any other number, suppose 5 raised to 2 by 3. So here in place of 1 there is 2. So again this will be cube root only, but it will be raised to 2 because the power is 2. Here there was no power, power was 1. So we did not do anything. So this is the way of writing the indices in the root form. Okay, for fractional indices we write it in the root form. Now let's take up an example also to solve the indices which are given in fractions, right? So if it is 4 raised to 5 by 2 and 4 raised to 1 by 2. Okay. So now if you see, we are using two laws here. First law, it is division, right? And the second law we will use at the end while writing the answer. If they tell you to write the answer in the root form, right? So here if you see, we will just subtract the power because the base is same and they are in division. So what do we do with the power? We simply subtract it. 5 by 2 minus 1 by 2. We can subtract directly because if you see in both the fractions, the denominator is the same. So no need to take the LCM or equalize the denominator. We can just directly subtract. 5 minus 1 will be 4. So this will be 4 raised to 4 by 2. Now if they tell you to write it in the root form, so what you do? This will be square root of 4 the whole raised to 4. Okay, and if they tell you to further simplify, you can simplify. What is square root of 4? It's 2. And 2 raised to 4. What is 2 raised to 4? It's 16. So you got the answer, right? You don't leave the answer like this. You simplify the answer till the time you are getting a answer. Okay, so you simplify it till wherever is possible for you. So that's it for today. I'll just give you a challenge question. Just solve and give me the answer below. This is having, I think, mostly many laws here. Just try out if you can. I will upload the answer in the comment. I will check the answer for those who are commenting the answer down. So please find the answer for this and do comment below. Thank you for watching. See you in the next video.